dear students. In the previous class, we had discussed about the hydrocarbons and also we have learned how to draw the electron dot structures for many compounds. And in the today's session, we are going to discuss about many compounds of carbon where carbon is bonded to atoms of different elements. Okay, let's get started. So far, we have learned about the hydrocarbons, that is the compounds containing carbon and hydrogen only. That is alkanes, alkenes and alkynes. And we also know that this carbon atom can be bonded to different elements, atoms of different elements, like the carbon atom, it can be bonded to atoms of different elements like nitrogen, sulfur, oxygen, chlorine, bromine, etc. Yes, the carbon atom can form covalent bond with the atoms of other elements also. And how these are formed? The hydrogen atom or hydrogen atoms of the hydrocarbons is replaced by these atoms, the atoms of other elements, giving rise to the different compounds. The hydrogen atom or atoms. One or more hydrogen atom can also be replaced by these atoms of other elements. Yes, the hydrogen atom can be replaced by the atoms of other element, resulting in new compounds. And this and these atoms of other elements replacing hydrogen are called heteroatoms. They are called as heteroatoms. And these heteroatoms may be also in group. They may be also present in the group. The heteroatoms can be present in group. And when these heteroatoms or group of these heteroatoms are substituted by hydrogen, means when hydrogen atom is replaced by these heteroatoms or group of heteroatoms, then the properties of that hydrocarbon will get completely changed and it will confer different properties to the compound. So these heteroatoms or group of these heteroatoms, they are called as functional group. Yes, these heteroatoms or the groups containing these heteroatoms confer different properties to the hydrocarbon. Yes, once the hydrogen atom of the hydrocarbon chain is replaced by these heteroatoms, then the property of that hydrocarbons will get changed. So they will confer some special properties to the hydrocarbon chain. So these are called as functional groups, as they confer different properties to the compound. They are called as functional group. Okay, these are called as functional groups. Yes, we are going to understand what are these functional groups. See here, we know that carbon atom can be bonded to atoms of different elements like nitrogen, sulfur, oxygen, chlorine, bromine, etc. And these are formed by replacing the one or more hydrogen atoms by these atoms. And these atoms of other elements replacing hydrogen, they are called as heteroatoms. They may be present in the form of group also. And these heteroatoms, they confer different properties to the hydrocarbon chain. So they are called as functional group. How they look? Let's see here. See here how the different heteroatoms are attached to the carbon chain. When the chlorine, bromine are attached to the carbon chain, then the functional group will be either chloro for chlorine atom, bromo for bromine atom, in this way. You can see the example. If the chlorine atom is attached to this carbon chain, this is a heteroatom here, and the functional group is called as chloro. This functional group is called as chloro. If it is bromine, then it is called as bromo, in this way. And this heteroatom can also be present in the group. For example, oxygen. This oxygen is present in the group here. This group is called as alcoholic group. When this group is attached to the carbon chain, then the compounds will be alcohols. Yes. For example, this is a carbon chain. The alcoholic group is attached to this carbon chain. This group is called as alcoholic group and it is the functional group here. And if this aldehydic group is attached to this carbon chain, then those compounds will be aldehydes. If this ketonic group is attached to the carbon chain, then it will be ketone compounds. If carboxylic acid is present in the carbon chain, then those compounds will be carboxylic acids. For example, here this functional group is of carboxylic acid. This is a carboxylic acid functional group. And these compounds are called as carboxylic acids. Means these functional groups, they will provide the different special properties to that compounds. So they are called as functional groups. Okay, these are some functional groups here. You have to remember these functional groups. Okay, it is very important to remember all these functional groups. Okay, now we have understood how these functional groups are attached to the hydrocarbon chain. Now we are going to study about the homologous series, which is closely related to these functional groups. Yes, the series of compounds which have the same general formula and same functional group, they are called as homologous series. Yes, the series of compounds with same functional group and same general formula is called homologous series. And we have learned that whenever a functional group is attached to the chain, it will depict the special properties to the hydrocarbon. Then it is regardless of the chain length. The chain length may be of any number of carbon atoms. It may be of 2, 3, 4, 5, 6. Regardless of the chain length, the functional group will confer the special properties to that hydrocarbon. Yes. Now let us see the homologous series of alkanes. The members of alkanes are CH4, C2H6, C3H8, C4H10 in this way. Okay, these are some of the members of alkanes. And you can see here between the two members, that is successive members of the homologous series, you can easily observe here there is a difference in the molecular formula by CH2 unit. You can also see these two successive members. Here also there is difference in the molecular formula by CH2 unit. This shows that in case of homologous series, the successive members of a particular series, they will be differing by a CH2 unit. You can take example for another homologous series. Let's take for example alcohols. They have general formula. Yes, they have the same functional group, that is OH. Let us write some of the members for alcohol. CH3OH, C2H5OH. C2H5OH is nothing but CH3CH2OH. This only I have written in the compact form. And also C3H7OH, C4H9OH. Here also you can take any two successive members here. They differ in their formula by a CH2 unit. Yes, this is about the homologous series. You can take any homologous series and write their members. If you take alkenes here, the members are C2H4, C3H6, C4H8, C5H10 in this way. Yes, they have the same functional group and the successive members, they differ in their molecular formula by CH2 unit. This is all about the homologous series. Now let's see what are the characteristics of this homologous series. All the members of the homologous series, they have same functional group. Yes, we know that if I take the series of alcohols, all the alcohols have the same functional group, that is OH. And irrespective of the chain length, they have the similar chemical properties. You can take methanol, you can take C2H5OH ethanol or propanol. These are belonging to the same homologous series of alcohols. All these compounds have the same functional group and they show the similar properties because of the functional group which is same. Okay, and they have same general formula. Members of homologous series have similar chemical properties. Yes, all the members of the homologous series they have same chemical properties and these chemical properties are mainly due to the presence of this functional group. In case of alcohol they have functional group that is OH and the properties of those compounds are due to this functional group. And the successive compounds of the series differ by CH2 group as we have seen already. They differ by a CH2 group. Yes. And in any homologous series, a gradation in the physical properties is seen. They show a regular gradation means gradual increase or decrease in their physical properties. Gradation means it is gradual. The change in the physical properties is gradual and those physical properties are somewhat comparable also. Yes, this is about the characteristics of homologous series. Now let us see some set of rules for writing the names of carbon compounds here. The first step is identify the number of carbon atoms in the compound. This is the most important step to be followed right while naming the carbon compounds. As we have discussed in the previous class only that the number of carbon atoms is indicated by the root words meth, eth, prop, but in this way. Yes, if there is one carbon atom, yes, if there is one carbon atom, the keyword will be meth. If there are two carbon atoms, the keyword will be eth. If there are three, we use prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. These are the keywords that we use for writing the number of carbon atoms. If there are 2, we use eth. If there are 3, we use prop. If there are 4, we use but in this way. Yes, you have to remember all these keywords while naming the carbon compounds. Yes, this is the first step. In the next step, the functional group is indicated in the name by adding suffix or prefix. First, we have to identify whether there is any functional group here. Then we will name that functional group by adding suffix or prefix. See here, if chlorine bromine atom is attached to the carbon chain, then we will use the prefix chloro, bromo, etc. Means if it is fluorine, we will use fluoro. If it is iodine, we will use iodo in this way. Yes, always prefix will be used for halogens. Remember, for example, if this is a compound. If this is a compound having the bromine as functional group here, we will indicate the name of this compound by writing the prefix here. Yes, bromoethane. Why we have given here bromoethane? Because bromo is the functional group, that is prefix, and ethane means it consists of two carbon atoms and there are no double bond here. So the name of the compound is bromoethane in this way. And if the name of the carbon chain is to be given as suffix, the name of the carbon chain is modified by deleting the final E and adding the functional group. See here, these are the suffix which are used when the functional groups are alcohol, aldehyde, ketone, carboxylic acid in this way. And while naming the normal hydrocarbon chain, if it is propane, yes, we want to name the compound that is alcohol. If this is alcohol, yes, this is alcohol. We have to name this compound. Count the number of carbon atoms here, 3. So the keyword will be pro. And it is not propane because functional group is present here. So the suffix is to be added because the suffix for alcohols is all. So the suffix will be propanol, means all will be the suffix here. Normal, the hydrocarbon will be propane. We are removing this E. We are removing this E and replacing this E by all, that is suffix. It is due to the presence of the functional group, that is alcoholic functional group. Okay. And if the name of the if the carbon chain is unsaturated, then the final A in the carbon chain is replaced by in case of double bond, and ine in case of triple bond. Yes, if the carbon chain contains any double or triple bond, we will indicate that by using the suffix in, and ine. In and ine are used if double or triple bond is present respectively. Yes, you can see here, for double bond we will use the suffix in. For triple bond we will use the suffix ine. Once we solve some of the example, we will clearly come to know how these compounds are named. Okay, let us solve some of the compounds here. Example, you can write propanol or ethanol. This is ethanol. It consists of two carbon atoms. So the keyword will be eth. Why ethanol? Because the functional group is alcoholic. So the suffix all is to be used. How do we use this all? By removing the last E of the normal hydrocarbon compound and replacing it with all. So the compound will be ethanol. What will be the compound? It will be ethanol. What in case of aldehyde? In aldehyde, we know that the functional group will be CHO. Yes, CH3, CH2, C. This is the aldehydic functional group. And while naming, you have to count this carbon atom also, because this is present along with the chain. So we will also take into account this carbon atom. So what are the number of carbon atoms here? 3. So the root word will be prop. Prop will be the root word. And what is the functional group? Aldehydic group is the functional group here. So propanol. Why do we use al here? Because the suffix for aldehyde is al. So it is propanol. If you use all, then it is alcoholic group. If you use al, then it is aldehydic group. Okay. What in case of ketone? Suppose this is a example. How do we name this compound? There are 3 carbon atoms. So the root word is prop. Then the functional group present is on. So I have to write on here. Propanone. It is propanone because the suffix when ketonic group is present, it is on. In case of carboxylic acid, how do we name this compound? First count the number of carbon atoms here. 1, 2, 3, 4. There are 4 carbon atoms here. So what will be the keyword? Bute. Yes, bute will be the keyword. And is it a simply hydrocarbon? No. This is having the functional group, that is carboxylic acid. This carboxylic acid is also written as COOH, or in the simplest form COOH, in this way. Yes. So the suffix that is used will be oic acid, because of which it will be butanoic acid. If it was a simply hydrocarbon, we had used butane, but it is not the simple hydrocarbon. There is a presence of group, that is functional group here. So we are using the suffix oic acid here. Yes, this is butanoic acid. If there is double bond in the carbon chain, see here, there is a presence of double bond here. Then what is the suffix that we use when double bond is there? It is in. So count the number of carbon atoms here. 1, 2, 3, 4. Yes, it is but. What will be the name of this compound? Butene. Because the suffix in will be used if there is double bond. Then when there is triple bond in the compound. Suppose this is a compound. We have triple bond here. So the number of carbon atoms are 2. So eth. So eth is used as the number of carbon atoms are 2. Then the suffix that we will use will be "ine." So it will be ethyne because it is triple bond. So we are using the suffix ethyne here. In this way, we are going to name the carbon compounds having functional group. And it is very important that you have to remember all these functional group along with their prefix and suffix, which must be used in case of naming. Yes, let us solve some of the questions here. Write the structures for the following compounds. First one is bromohexane. Let us write the structures for these compounds. Bromohexane. Hex means it is having 6 carbon atoms. Yes, hex means it is having 6 carbon atoms. 1, 2, 3, 4, 5, 6. And also the functional group is bromine here. So it is indicated by Br. Yes, we have to write here Br. Then satisfy the remaining valencies of carbons by writing the hydrogen atoms here. Each carbon should get 4 bonds. This is the structure of bromohexane. Hex indicates that it consists of 6 carbon atoms. So I have written 6 carbon atoms in a chain, and I have written bromo, that is Br for bromo functional group. It will be bromohexane. Okay, this is answer for A. For B, propanoic acid. Here prop is given, which means it consists of 3 carbon atoms. 1, 2, 3. Yes, including the functional group, it has 3 carbon atoms. And oic acid means it indicates the functional group is carboxylic acid. What is the carboxylic acid functional group? COOH. Yes, I will write here COOH. Including this carbon atom, we have propanoic acid. Okay, we should not leave this carbon atom. Overall, totally we are having 3 carbon atoms in propanoic acid. Okay, do not exclude this carbon atom. And write again COOH. Do not write that. Okay. Now satisfy the valency of carbon with the hydrogen atoms. This is propanoic acid. You have to remember the functional group formula. You have to remember the root word. Then you have to name the compound. Then you have to write the structure for the compound. Yes. Propanone. Yes, this is a third compound whose structure is to be written. See. Prop. Again, it consists of 3 carbon atoms. And one means it is ketonic group. What is the ketone group? CO. This is a ketone group. And these two ends are attached to the 2 other carbon atoms. Okay. So I will write here CO. This is a ketonic group. Okay. Then I will write the remaining valencies with hydrogen atom. Then I will satisfy the valency of carbon with hydrogen atoms here. This is propanone. Okay. Let's see the next compound. Pentanol. D. Pent means it consists of 5 carbon atoms. C, 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 C. And the functional group is al. Means it is aldehyde. What is the formula for aldehydic group? We know COH. CHO. It is aldehydic group. Yes. COH. And satisfy the valency of carbon by writing the hydrogen atoms here. This is a structure for pentanol. So overall what we have done? First we have to count the carbon atoms by seeing here the keyword. Hex means 6 carbon atoms. Hept means 7 carbon atoms. Pent means 5 carbon atoms. Then we are going to observe what is the functional group. And we are going to write the functional group in the structure. Next, draw the structural isomers for pentane. What is the structure of pentane here? CH3, CH2, 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 CH3. Means it consists of 5 carbon atoms. What are structural isomers? These are the compounds with same molecular formula but different in the structures. They have different structures but same molecular formula. For writing the isomers, What we can do is, we can arrange all the carbon atoms in a single chain, and one more compound I can write here by writing 4 carbon atoms in a chain and writing the 5th carbon as a branch. Then satisfy the remaining valency of carbon. This carbon atom also be bonded with hydrogen for satisfying valency. This is isomer of this pentane. This is one structure possible. This is another structure. You can also write it in the condensed form like CH3, CH2, CH. This group can be written as CH3, CH3. This is one isomer possible, and also you can write the compound as by writing the carbon atoms in a chain, that is 3 carbon atoms in a chain and 2 carbon atoms like this. This is also a pentane only because it is having the same molecular formula as that of this one, and satisfy the remaining valency of carbon. Already this carbon, the valency is satisfied, so no need to write the hydrogen here. Now I need to write hydrogen for this carbon atom. I can write it as CH3C. This group can be written as CH3, and this group can be written as CH3, and this also we can be written as CH3. This is also a pentane. These are the structural isomers for pentane. Yes, to summarize, how can we write the structural isomers? First, writing the all the carbon atom in a single chain. All the 5 carbon atoms in a single chain, and we should check the possibility of writing this carbon atom out of the chain also. Yes, we can write one carbon atom out of the chain like this. In the third step, I can write 2 carbon atoms out of the chain. When satisfying the remaining valencies of carbon, we will get the different isomers here. Okay, and you can check all of them are having this one, this one, this one. All of them are having the same molecular formula, only their structures are different. Okay, so I can write it as these are the 3 structural isomers for pentane. Okay, now name the following compounds. We have to name them. See here, there are 3 carbon atoms, so the keyword will be pro, and the functional group is ketonic group. So we will add the suffix on. So the name of the compound will be propanone. As this is a ketonic group, I should add suffix on here. So the name of the compound will be propanone. And in this case, there are 3 carbon atoms again. Again the root word will be pro. And what is the functional group? It is aldehydic group. So how will we write the aldehydic group? As a suffix al. We will use al. So the name of the compound will be propanal. Okay. Then see this example. There are 1, 2, 3, 4, 5, 6 carbon atoms here. And which is the functional group here? All the carbon atoms are in single bond, but here there is a double bond between the 2 carbon atoms. So the suffix I should use will be "-ene". The number of carbon atoms are 6. So hexene. This is the name of the compound. As there are 6 carbon atoms, I have written hexene because there is a double bond between the 2 carbon atoms. Next, this CH3, CH2, CH2, COOH. This is again carboxylic acid. It containing 4 carbon atoms. So but. And for carboxylic acid, we will use oic acid. So the name of the compound will be butanoic acid. This is how we will write the name of the compounds. And also we have learned how to draw the structures for these compounds.